Saturday, the 31st of August 2024, last day. I think we're 2 days before the new moon. I've been stretching myself a little bit, trying to figure out what kind of project I could take on as I await my continuation of the NGC project. Here's a look at the mountains. Last night we had quite a bit of haze, and there does appear to be a good deal of haze up on Cannon Mountain, possibly smoke. Anyway, last night I was out again with at a 75X, but I got a project for this evening. I'm not sure how it's going to play out, largely because so many of the studies I want to observe are westering at this point. Basically what I'm going to do is run the exposure time down quite a bit so I get some nice stellar points, and we're going to go after globular clusters. Okay, we're now seeing Messier 13 about 15 minutes later. It is now 8:30 in the evening. There's a better view. We are getting a little bit of aperture block, I'd say about 40% of the aperture, but this is finer than the one I got earlier which was only about 45 minutes after sunset. So I'm actually kind of pleased with this view. Let's go ahead and have a look at Messier 92 before we drop south into Scorpius. Here we have Messier 92, another globular cluster in Hercules, about a magnitude fainter, magnitude 6.5, and less than half the size, 11.2 arc minutes, 26,700 light years distant, puts it at about the same distance as Messier 13. We're at right ascension 1707 and declination plus 4308 11. I do believe we are getting a little bit of aperture block by the roof tries, but both these last views of Messier 13 and 92 could easily be considered late spring globular clusters, but I'm including them in this tour, which I'm calling summer globular clusters, at least the ones that I can get as we just about to enter into the month of September. Okay, we're going to have a look at Messier 80, otherwise known as NGC 6093, so it is kind of late in the summer. It's well past culmination to the south, but still visible above the garage roof. There's our look. I'll give you the data on it. And I will be giving you the data out of the NGC catalog so we can get a sense of its brightest stars and what class globular cluster it is. NGC 6093, globular cluster Scorpius, is Messier 80. Magnitude 7.3, smallish 5.1 arc minutes. Its brightest stars are magnitude 12.5, so they should be visible in a 5-inch scope. It's a class 2, so very dense, at 28,000 light years distant. Right ascension 161702, declination minus 225831. Developing on the screen now, we should be getting a view of NGC 6121, also known as Messier 4. Globular cluster in Scorpius. M4 is 5.4 magnitude, 26.3 arc minutes. It's of the size and brightness of Messier 13. However, it's much closer, and you'd expect for its brightest stars to be much brighter. Brightest stars in 6121 M4 are 10.8 magnitude. It's a class 9, a mere 7,200 light years distant, but you wouldn't want to drive there. We're at right ascension 1623.35, declination minus 26.31.34, and you should be able to see the characteristic line of brightest stars bisecting its core. This particular globular cluster is NGC 6205, also known as Messier 13. We're having even more of the aperture blocking going on, but it is darker out now, And I did want to include the data related to brightest stars, etc. Anyway, NGC 6205, Globular Cluster Hercules, Messier 13, magnitude 5.8, 23.2 arc minutes in size. Its brightest stars are magnitude 11.9 and should be visible through a 3-inch telescope. It's a class 10, so rather loosely constructed, 23,000 light years distant. We are at right ascension 164141, declination 3627, 35, and I imagine that's as good a view as we got earlier because we're now about 10 more minutes into towards sky dark. What we have here is NGC 6254, globular cluster of course, and Ophiuchus. It's also Messier 10, magnitude 6.6, 12.2 arc minutes in size. Brightest stars are magnitude 12, should be picked up in a 3-inch scope. It's a class 7, 14,000 light years distant. Right ascension 165709, declination -405, 55. Finally had a chance to synchronize, this time to NGC 6333, globular cluster Ophiuchus, also known as Messier 9. Magnitude 7.9, 5.5 arc minutes in size. Brightest stars at 13.5. Should be visible through a 6-inch telescope at the eyepiece. This is a class 8, 27,000 light years distant. Right ascension 17, 19, 11. Declination a mere -1830, 58. NGC 6356, another globular cluster in Ophiuchus. The snake charmer sure has called up a lot of stellar cities. Magnitude 8.2, 3.5 arc minutes in size. The brightest stars are magnitude 15. It's a class 2. Apparently one of the most dense globular clusters possible. 54,000 light years distant. Right ascension 17, 23, 34. Declination -17, 48, 51. I just synchronized the scope to it. There is some resolution of stars. Magnitude 15, not bad. 150x, 12-inch scope settings. Tuesday, September 3rd, a few minutes before 8 o'clock. We have been having more fires and smoke. Last night, started about midnight last night. I saw lightning off to the south and the west. NGC 6402, globular cluster Ophiuchus, is also known as Messier 14, magnitude 7.6, 6.7 arc minutes in size. The stars you're seeing resolved on the screen, now remember this thing is in pretty good focus right now, are magnitude 14. It's a class 8 cluster, which means middling diffusion. Anything from about, let's call it 4 to 8, is in the middle of the range of globular cluster density. We're at right ascension 17, 37, 36, declination -3 degrees, 14 minutes and 42 seconds. Not a bad look. I would like things to be a little tighter. I would point out that these, over here on the screen, these multiplicity of similarly brightness stars are actually artifacts that come out whenever you start pushing the shuttle speed and the sensitivity of the Rev2 system to fairly in decent range for astro imaging, real-time imaging, and they have been present on the screen since my first use of it, and we should keep an eye out for them and not confuse them for actual stars. Here we are getting a look at our first globular in Sagittarius, NGC 6440. Magnitude 9.3, 1.7 arc minutes in size. It's supposed to be the brightest stars are magnitude 16.7. I don't think they're being resolved. I think we're just getting some pixels. Nice to have turned this one up. NGC 6544, a globular cluster in Sagittarius. Magnitude 7.5, 8.4 arc minutes in size. Brightest stars 12.8, class 9, 8,200 light years distant, pretty close, considering Messier 4 in Scorpius is 72. Hard to understand how this one could have been missed by Messier and Machet in the late 1800s, even with a 3-inch scope. We're at right ascension 1807.20, declination minus 24:59.53. Well, here's a rather nice globular cluster. I'm sure hoping it is NGC 6626, and that it is. Globular cluster Sagittarius, and you might have guessed it, it's also Messier, number 28, magnitude 6.9, largish, 15 arc minutes in size. Brightest stars are magnitude 12, which you should be able to resolve with a 3-inch or maybe even slightly smaller scope, except for the sky position. It's a class 4, so on the more condensed end of the globular cluster rating scale. 19,000 light years distant, right ascension 1824.32, declination minus 24 degrees, 52 minutes and 6 seconds. Visiting NGC 6642, globular cluster in Sagittarius. Magnitude 8.8, that's that tiny one, 0.8 arc minutes, class 4, 25,000 light years distant. Right ascension 1831.53, declination minus 23:28.34. Okay, what you're seeing here is NGC 6656, globular cluster in Sagittarius, otherwise known as Messier 22. Brightest globular you can see from the northern hemisphere, however, if you're up in the Arctic Circle, not so well. This is Messier 22, magnitude 5.2, about the same size as Messier 13, 24 arc minutes in size. Its brightest stars are magnitude 10.7. It's a class 7, so not as impressive a globular cluster in terms of its reality, since it's only 10,000 light years distant. So it's less than half the size of Messier 13, which is probably somewhere around 250 light years in diameter. Right ascension 1836.24, declination minus 23 degrees, 54 minutes and 17 seconds. Okay, it's Wednesday the 4th, 2 days after the new moon. I have maybe 2 days, tonight and tomorrow night, to wrap up whatever deep sky imaging I want to do without any moon wash whatsoever. What I have before me right now is a sat clock. Unfortunately, the Gemini 2 mount is not able to get in touch with a GPS clock, so I have to, every once in a while, pull the one out of the bedroom, and then I have to synchronize. So let me do that now. Okay, it's now 8:30. Temperatures have cooled off a little bit. I'm going to see if the focus has been shifted on the scope due to temperature. One side of focus, outside I believe, inside no, I'd say it's pretty stable. With the summer triangle, high overhead, Vega just post-cometary, Altair further to the south and the east, and Deneb trailing it to the northeast. We are now getting a look at NGC 6712, globular cluster in Scutum. Magnitude 8.2, 4.3 arc minutes. Brightest stars are magnitude 13.3. It's a class 9, 22,000 light years distant. So here we are at NGC 6717, globular cluster in Sagittarius. Magnitude 8.4, smallest 3.9 arc minutes. Its brightest stars are magnitude 14. It's a class 8, 23,000 light years distant. We're at right ascension 1855.06, declination minus 22:42.05. Let's push onward and upward, and hopefully things will fall in with confidence. We're now seeing NGC 6760 on the screen. Globular cluster Aquila, magnitude 9.1, 2.4 arc minutes in size. If we're resolving any stars, they'll be of magnitude 15.6. It's a class 9, 24,000 light years distant. Right ascension 1911.11, declination 001 degrees, 1 minute and 49 seconds. Keep in mind, once again, we are operating at 64 flood, 42 decibels of gain, 6 passes, and we should be able to replicate viewing results except for the aesthetics of about a 12-inch telescope. Nice view. Here we have NGC 6779 Globular Cluster in Lyra, otherwise known as, drumroll please, Messier 56, magnitude 8.35 arc minutes in size. The brightest stars are magnitude 15, and I have seen about a half dozen or so of them through at the eyepiece of a 6-inch Maxitov Cassegrain. This is a class 10, 32,000 light years distant. We're at right ascension 19, 16, 35, declination 30 plus 30 degrees, 11 minutes and 1 second. Here we have a nice presentation, NGC 6838 Globular Cluster. I believe it's Sagitta. It's also known as Messier 71, magnitude 8.3, 6.1 arc minutes. We're seeing a little more resolution than we saw in Messier 56 because its brightest stars are almost 1 magnitude brighter at magnitude 12.1. And the reason we're seeing them brighter is because this is a mere 12,000 light years distant. We're at right ascension 1953.46, declination plus 18 degrees, 46 minutes and 41 seconds. That's a great view. It is NGC 6864 Globular Cluster in Sagittarius, also known as Messier 75, 8.6 magnitude, 6 arc minutes in size. The brightest stars, if they are resolvable, are magnitude 14.6. This baby is a class 1 globular, dense and packed with stars, some 60,000 light years distant. However, it would still be a bit smaller than the Great Hercules cluster. Then the Hercules cluster is probably somewhere around 175 light years in diameter, but what an intense view. Very nice and well positioned on the screen. And we are fairly south once again. Right ascension 20 hours, 6 minutes, 04 seconds, minus 21 degrees, 55 minutes and 18 seconds. Here we have a rather faint but largish NGC 6981 Globular Cluster in Aquarius, also known as Messier 72. It's hard to believe they picked this out with that 3-inch non-achromatic refractor in the late 1700s. M72 is magnitude 9.2, 5.9 arc minutes in size, but its brightest stars are magnitude 14.2. It is a class 9, 55,000 light years distant. Right ascension 2053.27, declination 12 degrees, 32 minutes and 14 seconds below the celestial equator. And that be our view. What we're seeing here is NGC 7006. And what kind of deep sky study is it? A globular cluster. Fairly far north above the equator. It's in Delphinus. Faintish, magnitude 10.6, smallish 2.8 arc minutes. Brightest stars are magnitude 15.6. This is class 1. I've mentioned this one before. 133,000 light years distant. Lies well beyond the bounds of the Milky Way galaxy. This baby is an intergalactic wanderer looking for a new galactic home. That we'll see in about 5 billion years. It's at right ascension 21 hours, 1 minute, 29 seconds, declination 16, 11, 14. We're now up to 7,000. The scope is close to culminating. I think I'll push all the way to the 7,100 this evening, and we'll call everything up to 7,100 late summer globular clusters. Folks, we didn't quite get to NGC 7100, nor do we need to do so, because we have now called up what I would consider the very first globular cluster of fall, which, by the way, is some 15 or a couple of weeks away. This is NGC 7078. It's a globular cluster in Pegasus, otherwise known as Messier 15, a very spectacular representation of a globular cluster. Magnitude 6.4, about half the size of the Great Hercules cluster. This one's at 12 arc minutes and 12.3 arc minutes. The brightest stars, which are well seen on the screen, are magnitude 12.6 and should be viewable through a 4-inch scope. It's a class 4, which means a more condensed version of a globular, 33,000 light years distant. Right ascension 21, 29, 58, declination plus 12 degrees, 10 minutes and 1 second. A very fine view. Another of the early fall globular clusters, Messier 30, it's in Capricorn, magnitude 6.9, 8.9 arc minutes in size, some 26,100 light years distant. It's about 2/5 the size of a similar of Messier 13, Great Hercules cluster in terms of apparent size and roughly the same distance. We are at right ascension 21 hours 40 minutes and 22 seconds, declination minus 23 degrees 10 and 45. And I think I mentioned, boy, it's getting a lot of atmospheric wash, isn't it? At least from my perspective. I do believe I mentioned the fact that the right ascension position of deep sky studies begins, I believe, at some point in the past. I think it was the year 2000, adjusted now. At the time of the winter solstice is 0 hour. So if you progress through the seasons, and you got 4 seasons in 24 hours, 0 to 6 would be the winter. Hours 6 to 12 would be the spring. Hours 12 to 18 would be summer, and hours 18 to 24 would be the fall. Well, it just so happens that the days are longer and shorter, which means it either pushes back or compresses the hours in which you can actually observe at astronomical dusk and dawn if you happen to want to get up early in the morning. So what we've just done over the last 3 videos is covered globular clusters that present themselves at a time of night of sky dark during the summer observing season. And I can remember when summer nights were at their shortest and days were the longest, that I would have to get out at 10:15 to 10:30 at night just to get a dark sky. Well, it's now a couple of months later, and the dark sky is occurring around 9:15, so we've shaved about an hour off of it because the sun is rising later and setting earlier. So there we go. This and Messier 15 are well placed in the sky for those who wish to observe earlier and earlier in the evening during the early fall. Carpe Noctem.